The big payoff. This is an idea I had a long time ago, and I'm excited to finally get here after 3 sessions of talking about it. But I think it's a really big idea that may shape how we do business for a while. So the idea is to bring KCS, intelligence swarming, together to improve agents. And I talked through this whole presentation about some kind of more nuanced, smaller ways that happens, storing long-term memory and stuff like that, right? So that's kind of the granular pieces. Stepping back a little bit and thinking a little more high level, let me walk through a flow. And an agent matches on work if we're using intelligent swarming with agents, being able to do the matching. The first thing they should do normally is they search for knowledge articles, right, to try to solve that. But now in this world of agents, what they could be doing is they could be searching for matching work from the past and then looking at the decisions that agents made or the workflow that agents used to come to successful outcomes. And now they're using, instead of a knowledge article, they're actually using decisions as a source of knowledge, and they're reusing those decisions. So think about reusing agent flows as part of your KCS process more than just reusing knowledge. And when you reuse those successful outcomes, there's a couple of cool things that happen. I wanted to get to the big why on this. So the first one is reducing variability. So LLMs are non-deterministic, and what that means is the output from an LLM is probabilistic. You feed it a bunch of words, and those words get turned into numbers. The numbers go through a whole bunch of linear algebra and come out the other side as other numbers, and then those numbers get turned back into words. But what really happens is on the other side at the back end, there is a probability distribution. So what it says is like, this word has the highest probability of being correct. Maybe it's 85%, but this next word has a 75%. And that's not quite how you should interpret these probabilities so an academic would be upset about this, but you can think about it this way, that, the second best result has a 70% chance of being right. And the third one maybe only has a 40%. So it has this like ranked list of what your outcome should be, what the next best word is in this case. And usually, depending on what you set, you've probably heard of temperature. If you set your temperature at 0, it'll always just pick the top result. But you can set your temperature a little higher than 0, and it'll pick the top result most of the time, but sometimes it picks lower in the list. All machine learning academic stuff you don't have to worry about, but the point is there's this probability distribution at the end that makes LLMs non-deterministic, which means that you can have variance in responses. So you can give it the same piece of work twice, and one time it'll say, here's the process, and you'll get an outcome. And another time it'll say, well, here's a different process, and you'll get a different outcome, which is not ideal. You probably have one outcome that's better than all the other outcomes. So it's worth capturing when agents do that correctly and they pick the right outcome, and then reusing that rather than rely on agents to think about it again and introduce that non-determinism. So now you've got, every time the agent sees that same piece of or that same type of work, it can use the same flow and get the same desired outcome. So that's one big thing. Removes a lot of the chaos around using agents, the surprises, I should say, when you see different outcomes than you expect. Number two, it can improve quality. So capture the workflows and have them be reviewed by humans to fine tune them. So we got to the right outcome with this workflow, but there's a step in there you just didn't need. It's just not useful. It came up with information that was not important. And so we can just cut that step out, get to the same outcome, more efficient, the customer's happier. A human can see those kind of things where the machine might just be like, hey, we got to the good outcome and it worked great, right? Humans review it, gets reused, humans review it, gets reused, and outcomes improve because of that. Number three, it reduces token costs. So one of the big things is like all of these agents, putting them in where it's kind of expensive or can be expensive. And I'm a big proponent of using lots and lots of content. You've seen that through these sessions. The more content, the better. It gives you better outcomes by grounding. But content that translates directly into tokens. The more content you feed, the more tokens you're using. So if you can get your agent to use a bunch of content once and get to the right outcome with the right flow and then reuse that, you don't have to spend all of those tokens to do the same thing over and over again. So it's going to make things a lot cheaper. And it's going to improve scalability. Some of the organizations I work with have a huge scale problem where, like just agents operating at scales you wouldn't believe. And even with the best infrastructure, it's hard. It's hard to do that in a timely fashion. And so you end up with things like, when you interact with an agent, it sits there and thinks for a few seconds and shouldn't have to wait for that long, right? Where if you can reuse stuff, you don't have to wait for the agent to think. You don't have to worry about that scale. Things happen immediately because you've already got the answer, right? So this is my proposal to move from KCS from beyond just looking at content, just knowledge, and start thinking about how to capture agent workflows and apply KCS principles to the actual agent workflows and decision making.